Hello, class. I received a question on problem number 3 from the 8.2 homework assignment. Think of this problem as a bag of M&Ms, right? Imagine you had a bag of M&Ms and there were green M&Ms, orange, blue, red, yellow, and brown. And the manufacturer says, if you were to open up a random bag of M&Ms, 13% would be brown, 14% would be yellow, and so on. So one of my curious statistics students wants to see, is that claim correct, right? They want to test whether the bag of colored M&Ms follows the distribution as stated above. So the first thing we need to do is create a null alternative hypothesis. So the null hypothesis would be that the distribution is the same as stated by the manufacturer. And the alternative hypothesis would be that the distribution is not the same as stated by the manufacturer. I check my work, I get it well done, great. Next, we're looking for the expected count, right? So I need to add all of the M&Ms together and then multiply by these percentages to see what my expected count would be. And I can compare the actual count or the observed count versus the expected count. You could quickly sum this up in your calculator, or you could use StatCrunch. So I click on the table for my data, and I realize usually there'd be another button here that would open this up or allow me to copy this into StatCrunch, and I realize that has not happened. So I will click Question Help and StatCrunch, and it opens up StatCrunch for me. So now I can quickly just type, luckily there's not too many values here. I can type in the 63, and so on directly into my table. And, again, if I did this in Excel, I could quickly sum this. In StatCrunch, it's a little bulkier. I click Data, I click Compute Expression. I'm going to build an expression. The sum feature is here, right? So sum, and it's variable 1. And I think that should do it. Let's see if I can make this a little bit bigger. And I just realized the sum feature did not work. Let's try that again. I scroll down to sum. I double click, there it is, and variable 1. So let's see what this looks like. Right, so I'm going to sum variable 1, I press OK, and I'll just put count. And under column count, it looks like there's 387 total. All right, so I'm going to fill in all of these with 387. And what I want to do next is multiply 387 by the expected probabilities up here, right? So for brown, we were expecting 13%, so I'm going to put in 0.13. For yellow, we were expecting 14%, 13% for the red, 24% for the blue, 20% for the orange, and 16 for the green. So these are my probabilities, and they were given to us from the problem. I'm trying to, let's see, I can minimize this for a second. Right, so those probabilities were given here, okay? So now, to get the expected count, we can just multiply this column versus bar 3, and we'll get our expected count here. So again, I'm going to press Data, Compute. I want to multiply, let's see here, we'll hit Build. So under Count, I want to multiply that by what I have in column bar 3, and I'll press OK. And I guess we can call this expected. And then I press Compute. and these are my expected values. Okay, so I need to enter this to 2 decimal places, right? So the 50.31 and the 54.18 and so on, all of this needs to be entered into the expected count. Okay, so I multiply the probability by the actual number of candies, and I should get what I would expect to see. And notice this column is what I actually saw, right? So these were the observed values. These are the expected values. So let's minimize this and check our answer. And we get a good job. Next, it says, what is the test statistic? Okay, so if we were to press stat and the goodness of fit, we can do the chi-square test, right? Because it does say x squared here, right? And for the observed, we can enter this column var1, right? This is what was observed, the 63, 63, 52. And the expected, let's see if I can shrink this a little bit. That was the data that was stored under expected. So for expected, I'm going to select the column called expected, right? So observed was this var1, and the expected was what we calculated by multiplying the count by the probabilities that were given. And we multiplied these two together to get this column. And I'm going to press compute. Ooh, having mouse troubles today. I press compute. And here is my test statistic. It says go 3 decimal places. So it looks like 14.649. Let's put that in here. And let's check our work. I press check answer, and we get the good job. And then the p-value of the test looks like the p-value is 0.012. And that's also, we have to round to 3 decimal places. Oops. Excuse me. I think we said 0.012. Let's just double check that. 0.012, yes. And I press check answer. Yeah, fantastic. So since the p-value is less than the level of significance, that means we reject, right? So my choice is either going to be B or D. So we reject the null hypothesis, which means there is sufficient evidence that the color distribution of the colors is not the same, right? If we accepted the null hypothesis, then we're saying that the distribution is the same as stated, right? These percentages are accurate. But since we're rejecting the null hypothesis, we're saying that these values are not accurate, right? So there is sufficient evidence to conclude that the distribution of colors is not the same as stated by the manufacturer. I check answer, and we get the good job. I hope that helps. Thank you for watching.